Welcome to today's deep dive. Today, we are exploring a highly technical source. It's a product page from HDTVSupply for this piece of broadcast equipment called the AJA FiDO-R-SC.
Yeah, it's quite the name, but, decoding it is pretty fascinating.
Right, and the mission for you, the listener, today is to decode this heavy tech jargon and really uncover the invisible backbone that makes massive live video productions possible. Because live broadcast environments face a brutal physics problem.
Oh, absolutely.
You've got these massive streams of uncompressed 1080p video, which is that 3G-SDI standard data, and it's like trying to blast a literal fire hose of data through a mile-long garden hose without losing a single drop.
That is honestly the perfect analogy, because pushing an uncompressed 3 gigabit per second signal over your standard copper SDI cable, it maxes out at just a few hundred feet before the signal completely degrades.
Right.
So productions have to switch to single-mode SC fiber optic runs, and the FiDO-R-SC, it sits right at the end of that fiber line.
Okay, so it acts as like a translator.
Exactly. It takes those optical light pulses and turns them back into an electrical 3G-SDI video signal.
And performing that conversion at the receiver allows for a 10-kilometer cable run.
Yeah, 10 kilometers.
Which is, wait, that's over 32,000 feet of track? That's insane.
It's massive. It changes the whole game for live events.
But looking at the source from HDTVSupply, they heavily market the device's electrical isolation to eliminate ground loop problems.
Right, yeah.
If it's just moving light through fiber, why is electrical isolation such a huge selling point here?
Well, think about the environment at the end of that 10-kilometer run.
Yeah.
You usually have this massive mobile broadcast truck.
Oh, sure.
And you've got dozens of monitors, switchers, audio boards. They're all pulling power from different generators or shore power hookups.
Oh, I see where this is going.
Yeah, that creates voltage differences across the equipment ground. So if you connect everything with traditional copper cables, those voltage disparities, they flow straight through the video lines.
Which creates that nasty electronic buzzing, or those visual rolling bars that ruin a feed.
Exactly. But because the incoming signal on the FiDO-R-SC arrives as physical light rather than an electrical current, the conversion process itself acts as a firewall.
Oh, wow. So it literally breaks the continuous electrical circuit.
Yep. The voltage chaos in the truck just can't travel backward up a beam of light.
That physical air gap is crucial. The optical conversion basically quarantines the truck's electrical noise so that pristine video feed coming from the camera miles away remains perfectly clean.
Right. But that quarantine only works if you can physically fit the receiver into the truck's ecosystem.
Which is tough, right? Space is at an absolute premium behind those equipment racks.
Oh, yeah. Which dictates the form factor. The footprint is essentially the size of a thick deck of cards. It's 4.6 by 1.7 inches.
And less than an inch thick, right?
0.85 inches. And since it draws a maximum of only 2 watts, it doesn't add a massive thermal load to a cramped, unventilated space.
That's super important.
Totally. It's rated to operate in temperatures up to 40 degrees Celsius, which is pretty typical for a dense equipment rack.
And I noticed it's not just translating the signal either. The specs show it cleanly passes all the SDI metadata through, including HDR.
Yep, it handles data rates dynamically from 150 megabits up to that full 3 gigabits per second without any configuration.
And it features dual matching SDI outputs. So it seems like instead of needing a separate distribution amplifier to, split the signal once it's converted to electricity, this tiny box can feed 2 completely different destinations at once.
It simplifies the entire signal flow behind the rack. You can route one output directly to the live broadcast switcher for the live cut.
And send the second output straight to a recording deck for the archive.
Exactly.
So for a $585 piece of gear, backed by a 5-year warranty, you're really looking at the invisible 2-watt workhorse-keeping major live events from turning into a pixelated, buzzing mess.
It operates completely in the background, but the entire infrastructure of modern remote broadcasting relies on these conversion points.
But, consider the trajectory of broadcast standards for a second. As productions inevitably shift from 1080p to uncompressed 4K, 8K, and beyond, the data rates are going to easily dwarf that 3 gigabit ceiling.
Definitely. The demand just keeps growing.
Right. So will the physical bandwidth limits of these tiny 2-watt converter boxes eventually force a total redesign of how live video is captured and routed? Or will the fiber infrastructure adapt to handle the heavier load?
It's a great question.
It's definitely something for you to chew on next time you see a crystal clear shot from a camera stationed miles away from the action.